Hello friends, today we'll solve one numerical on DIT-FFT. Suppose x of n is an 8-point sequence written here 2, 2, 2, 2, 1, 1, 1, 1 and 0 point is here. So n is equal to 8 and we want to find FFT. Okay, actually there are several mistakes that one makes in solving this. So I thought of making one video on it, and I'll give you one bonus tip at the final stage how to calculate the sum of the samples directly, okay, from the half of the samples we have calculated. Okay, so first we'll start with drawing this figure. Okay, so this structure it offers the stage 1 butterfly, then stage 2 and stage 3, or you can draw reverse, but keep some place here to write the numbers because the Tweedle factors here are somewhat larger than compared to this. The Tweedle factors here at this point is W80, that is equal to 1. So I'm not writing this W80 is equal to 1 here, okay, because this is going to be the same number. Okay, first of all, write the sequence in scrambled sequence. We have seen that bit scrambling process, that is bit reversal process, in our previous video. So scramble that and just we'll write the samples. So first, this is 0th sample, first sample, second, third, fourth, fifth, sixth, seventh. Okay, just write down this because we make a lot of confusion here writing the numbers. So x of 0 is equal to 2, x of 1, where is x of 1, that is equal to 2, x of 2 is equal to 2, x of 3, the sample is also 2. Rest of the samples are 1, so I'm writing it directly. Okay, you don't write it directly. Please check the samples are same, that's why I'm writing it directly. Okay, otherwise we have to check which sample is which sample and write it properly. Okay, I have not written the Tweedle factors here. So Tweedle factors are W80, W81, W82 and W83. These 4 factors are used, but most of the times we don't remember what is the Tweedle factor. Okay, so we just remember W80 is equal to 1. So I'll teach you one technique. We have drawn it several times. We divide this circle into 8 parts. Okay, for W8 we divide this circle into 8 parts, and this is the axis, real axis and imaginary axis. So this is a W80. Go on writing like this clockwise: W81, W82 and W83. W84, W85, 6, 7, these are not required first. So I'll write only these. So W8 is 0, I'll write it by different color. This is 1, this point is -1, this point is J and this point is -J. These 4 you can remember so easily. So W82 is -J. So I'll write this -J here, and this point is 1. Okay. So here this point W81 is on the real side and negative side of the imaginary axis. So we can write it 0.707 minus J 0.707 like this. So I'll write it here: 0.707 minus J 0.707. Okay. Now this point is on the negative side of the real axis, negative side of the imaginary axis. So both of them are negative. 0.707 minus J minus 0.707 minus J 0.707. So I'll write it here: minus 0.707 minus J 0.707. Okay. So we have written these numbers. So here we need only two, W80 and W82. So W80, W82 at this point. So 1 is only required, and minus J at this point also 1 and minus J. Okay. So what else is remaining here to be written? Let's see. We have to write minus signs everywhere. So this is very important thing. Minus 1, minus 1, minus 1, because we are going to subtract at the downward direction. Minus 1, minus 1, minus 1, minus 1, and here these 4s are, these 4 are minus 1. Okay, so going upward we are going to add, and going downwards we are going to subtract from the upper number. Okay, so we'll actually go on solving this example stage wise. In the first butterfly structure, we'll do 2 plus 1, 3, 2 minus 1, 1. Again here similar, 3, 1, 3, 1, 3, 1. Okay, so this is stage 1 output. Now we'll use this 3 and this 3. So it will become 6. 3 plus 3 is equal to 6. Now 1 plus, now we have to multiply this j to this 1. So 1 into minus j, so it will become minus j, 1 minus j. Okay, now 3 at this point we need 3 minus this is equal to 0, and now we need here minus j minus 1 multiply. So minus plus, so it will be 1 plus j. Okay, so these 4 points are same as these 4 points, so these outputs will be same here. Okay, so I'll write similarly 1 minus j, 0, 1 plus j. Okay, so at somewhat easier calculations are there up to this point, but when we go to multiply this, somewhat the answers can become wrong if we not make these calculations very properly. Okay, so I'll calculate it. You can do it on calculator, but I will make simple calculations here. 0.707 minus j, 0.707. Okay, we want to multiply this too. This is easy calculation. So first we'll multiply it by 1. 0.707 minus j, 0.707, this is equal to, now I'll multiply it with minus j, 0.707 minus plus, but j square is minus 1, so it will become minus again, so 0.707, so this becomes a real part. So this minus this, it will become 0. Now minus j, this plus this, 1.414. Okay, so this is our answer. So I'll write it here. This is minus j, 1.414. Okay, now this answer is also the same. I have calculated it, but I suggest you to calculate this again and please check. Now at this point, 0 into minus j will be 0. 6 into 1 will be equal to 6. So I'm not writing it. So now we'll calculate the final answers. Now observe here, final answers are provided in a sequence, so you don't need to scramble the sequence as you need in DIT-FFT. You need to write the sequence properly, because in DIF the output sequence is scrambled. So here it is in proper fashion, so you can go on calculating. So I'll write the final answers. 6 and this point is 6. 6 plus 6 is equal to 12. Now this 1 minus j plus this minus j, 1.414. So real part is 1 minus, so minus j, and this 1 and this, so it will become 2.414. Okay, 0 minus plus this 0 will be equal to 0. Okay, Now 1 plus j and this plus this. So real part is 1. Here no real part is there. And is plus j and this minus. Okay, so it will become minus j 0.414. Okay, so this is so easy if we do it very calmly. Now at the downward side we have to take this minus. So 6 minus 6, this is equal to 0. Now I'll tell you that bonus technique. You want to calculate these points, but it needs a lot of concentration to calculate those points again. So I'll tell you that technique. So this technique is applied when you are using the input which is real. Okay, so real sequence is there, then we can use the conjugation property. X of k is equal to x star of n minus k. Okay, so we want to calculate now x of 5. So we'll see x of 5 is equal to x star of 8 minus 5. So x star of 3. Okay, so x of 3 we have calculated. Now we have to take conjugate of x of 3. So 1 minus j, that will become 1 plus. Okay, so it will become 1 plus j 0.414. 0.414. So this is easy calculation compared to what we do, because here minus symbols are also involved. So calculation can become wrong, or just otherwise you can check the answer after the calculation. Okay, so x of 6, we can say x of 6. Now x, if you want to calculate x of 6, 8 minus 6, so x star of 2. X of 2 is 0, so here the answer is 0. Now x of 7. X of 7. X of 7 means 8 minus 7, x star of 1. X star of 1, this is x of 1, so you can write x 1 plus j 2.414. Okay, so this is how these calculation can be made so easy. So just with a little bit of care while making the calculations, you can reach to the correct answer. Thank you.